Hello. What we want to look at today is another example of projectile motion. And in this problem we're going to look at something. We have some object that lands 100 meters away and it's in the air for 10 seconds. So its time of flight equals 10 seconds. It comes from here and lands on the ground 100 meters away. And what we want to know is what was the launch velocity. So that means we need the speed and angle. And what was the maximum height? A lot of times you're given initial conditions and you find where it's going to end up. This time we know where it ended. How did it get there? So these are what we're going to look at. Well, there's several things we can take advantage of. The first is we remember that at the top, the time to the top was equal to 5 seconds. V at the top, Vy top, is 0 meters per second because it stops up there. We know that x initial equals 0 and y initial equals 0. We know that x final is equal to 100 meters. And so we have some information to start with. Equals 0 meters as well. It lands back on the ground. So what can we do with all this information? This plethora of information. We remember we have our equations of motion. V final is V initial plus A delta t. We have V final squared is V initial squared plus 2A delta x, where that can be x or y. And we have x final is equal to x initial plus V initial delta t plus 1/2 A delta t squared, where this x's could be x's or y's. We can get the initial x velocity, so we know that 100 meters is equal to 0 meters plus the mysterious v initial x times our 10 seconds. So we see that the velocity initial in the x, or x initial, is 100 divided by the meters divided by 10 meters per second, not 10 meters per second, 10 seconds, which is 10 meters per second. So that's how we now know one thing. We know that we initially launched the projectile in the x. Vx initial is 10 meters per second. What else do we know? Well, we can also figure out how fast we launched it in the y. We can use this equation, again, the position equation, because we know y final is y initial plus Vy initial delta t plus 1/2 Ay delta t squared. We know that y final is the same as y initial, so 0 equals 0 plus what we're looking for, Vy. We know the time was 10 seconds minus 1/2 of 4.9, or 9.8, times 10 squared. So we take 10, that's 150, well this is roughly 10, 5, this is equal to 0, 0, plus 10 Vyi minus roughly 500. We can move this over, so we get 500 is equal to 10 Vyi. Vyi should be equal to about 15 meters per second. So now we know Vyi. We've got a lot of information already. We haven't really done too much work. So how can we get the total velocity? Well, we remember that v, the velocity of the launch, is the square root of Vxi squared plus Vyi squared. Then we take the square root. So V launch is the square root of 10 squared plus 50 squared square rooted. So V launch, when we plug this into our calculator, and we see that V launch is about 51 meters per second. So that means we launched it with the speed of 51 meters per second. How do we get the angle? There's several ways we can do it. This is Vxi, and this part of the triangle makes Vyi. So our angle theta, we can find it from any one of the sine, cosine, or tangent. And so we can just use the tangent of theta is going to be Vyi over Vxi. We see that theta is the inverse tangent of our Vyi over Vxi, so it's 50 over 10, so it should be the inverse tangent of 5. And we get a launch angle of almost 79 degrees. And now that we have Vyi, this one or this one, to get the height at the top, so let's do that. How high up did we go? Well, y at the top is equal to y initial plus our Vy initial delta t plus 1/2 ay delta t squared. So y at the top is equal to 0 plus our initial 50 times the time we used to get to the top minus the 1/2 9.8 5 squared. And so we see how high up did we go. We have 250 minus 25 minus 125, and y to the top is 125 meters. This actually goes up a distance of 125 meters in the air before it comes back down. So even though we only started with knowing how far away it landed and how long it took to get there, we were able to figure out the angle it was launched at and the speeds it was launched at to get over to where it landed, and we were able to figure out how high it went. So this is just another example of how we can use our motion and x direction, motion and y direction, put them together to get our parabola using our standard equations of motion, and we were able to figure out, we were able to recalculate where something came from. Now this was taking advantage of the fact that we had a parabola as well.